Hello everyone, welcome to pyrevise. Now we're going to discuss about boolean, then numeric data types, that is integer, float, non-decimal integers, then complex number, and then we'll talk about strings. So let's start with boolean first. Boolean has two values, true and false. You have to remember T capital and F capital in Python. That's how you get boolean true and boolean false. You can use them in OR and not conditioning. You can see the truth table here. Then you can use a bool function. What does bool function do? If you have bool of a empty list or empty string, a boolean of false, boolean of none, or boolean of 0, this all evaluates to false, while boolean of any value inside a list or string is there, which is not empty, boolean of true, a boolean of any number, this all evaluates to true. So you can use this boolean in your condition checking for your loops and all. This is how you use boolean. Then we'll talk about numbers. First we'll talk integers. Python has both positive and negative integers. This is how you define an integer. A is equal to 12. You don't need a data type specifically like integer A12 because Python is dynamically typed language. So Python understand once you define A equal to 12, you take a type is a built-in function. It gives type integer. Same way you can have negative integers, type of -3. Again it's an integer, or you can use int function, convert a number or typecast a number into integer. You can perform mathematical operations with it like subtraction, addition, multiplication, and this is how you get the power. You all have built-in functions for this power and all, and this is a division. It gives you 4. This is an integer division. 8 by 5, it gives you 1. No no decimal point here because it is an integer division. If you want a decimal point, the exact output, you should have to give a decimal point in either numerator or denominator. That Python considered it as a float and gives you a float output. So this is a quotient, you get 1, and this is how you take modulo, or that is reminder. This is how you play with integers. Then we talk about float. So with a decimal point, Python understand it is a float. This is how you take it. Has both positive as well as negative float values. Type 8 by 5, that's what I was talking about. So here we have not given any decimal point to consider Python it as float. Or if you are not going to do a decimal point, you can even use a float function. So Python consider that as a float. This is a typecasting of integer into float. So you can use either decimal point or a float function to convert a number or integer into float. So then there's a rounding off. Every time when you talk about float, we need to round off the float values with a decimal point. So there is a round function. So we are rounding up to 3 digits till 7. 4 is less than 7. So Python consider 2, 5, 6, 7. That is a normal rule. So it will keep 7 at 7. If it is a bigger, same as 7 number, it will round up to next value. That is 5, 6, 8. So Python follows the normal rounding off rule. Then precision. Generally, Python has a precision up to 53 bits, but it depends on varies on machine to machine. If you want to see a precision of particular machine or particular Python value, you have to import a decimal module. Then pass your value to it. You get here, you can see it is a 56 bit, that is depending on my machine. So it's generally around 53 bits. Then we'll talk about the important question, the range versus xrange. It will be asked you too many times. So when you say range of 10, it evaluates to a list. But when you say xrange of 10, it evaluates to xrange object. So when you take a type of range 10, it's a type list. When you take a type of xrange, it's a type xrange. So what happens here? So you get a size of range 76. That is the size of a list loaded in a memory. While size of xrange just 20. So xrange saves a lot of memory space because it evaluates lazily. It's not an iterator, but it evaluates lazily and gives you number one by one. But when you use them in for loop, you'll not understand it works both, looks like works the same way, but main advantage of xrange or range is the memory saving. Then we'll talk about non-decimal integers. First, binary. When you append 0 capital B or small b to the start of a number, Python considers as binary. You can have 0b113, 0b11, that is 7. You can perform mathematical operations with them. Same way you have octal, you append 0o or 0 capital O in front of number, Python considers it as octal. Same way you can have hexadecimal numbers, 0x or 0 capital X to the start of the number, Python consider it as hexadecimal number. Or you can use bin, oct or hex function to convert an integer or number into binary, octal or hexadecimal respectively. Then we'll talk about complex number. Yes, Python also support complex number. If you take type 1 plus 2j, a plus ib format, it is a type complex. Or you can use complex function, pass two value to it, real and imaginary. It gives you a complex number. So let's say you have a complex number, z is equal to 1 plus 2j. So how Python stores it? It stores in a two part, z dot real, stores the real part, z dot imag, stores the imaginary part. So if you want to access in your program real part and imaginary part of a complex number stored variable, this way you can use it. If you take complex of true, you get 1, complex of false, you get 0j. You can have mathematical operations on it. A and 2 complex number I have defined, a plus d, you get the a plus 6j. So these are different modules. You can use a number, math, CMath, decimal, fraction, random, and so many. Random module helps you to generate random numbers. We will talk about strings. How you can define a string. In Python, you can define a string in double quotes, single quotes, as well as triple quotes. So this is our string, Harry. And if you take type as shown in a triple quote, it's string. So if you define it single quote, double quote, or triple quote, Python always considers a string. Strings are indexed. How? So a Harry, it is indexed positively 0, 1, 2, 3, 4. So you can access any particular alphabet in a string. A of 4, you get Y. Same way they are negatively indexed from backside or reverse order from -1, -2. So you can access the same Y variable using A of -1. So strings are positively and negatively indexed. Then slicing, you can slice a string. You can take a slice of A of 0 to 2, HA, slice of string. Same way you can use negative indexing to take a slicing of a string. Then we'll talk about concatenation. You can concatenate a string. The simplest way to use a plus operator, A plus B plus C. So Harry met Sally. That's A we define here. A is Harry, B is met, C is Sally. I'm concatenating all three using a space in between. So we get Harry met Sally. And then we'll talk about immutable property. So strings are immutable. So let's say if you're trying to assign in Sally C or C string, that is Sally, n to the third index, Python will not allow you because strings are immutable data types. Then we'll talk about typecasting. So you want to type print I have rupees plus 12, that is string plus integer. Python doesn't allow you because it cannot concatenate string and integer objects. So what you will do? So first you will typecast integer into string. This is the simplest way to do it. Use a string function and you can get your 12. Or this is a more pragmatical way, you can use percentage s sign, that is a string sign, and this is a syntax to do it. So you get typecasted print statement. This is how you can use in programming. This is all about boolean, numbers, and strings. Thanks for watching.